Right. Okay. So we have discussed up to the sorting and searching algorithm and this insertion sorting and all we discussed. And now actually we have discussed about the data structures stack we discussed last day, including the implementation. And so let me explain the search part actually. So before starting the binary search, you have the binary search algorithm, which we are basically binary search applied for the sorted list, ordered or sorted list.
Yeah.
Here you can see repeated checking of the middle item in an ordered list and discarding the half of the list when does not contain the search item. So binary search is basically applied for the sorted list. Okay, assume that. So let's take a word file and just to write. Okay, assume that you have a list like this, and this list is sorted, right? If this list is sorted, and in binary search, what will happen? It will first access the middle item, that is 65. So let's say we are searching for, we are searching for, okay, we are searching for 130. If you are searching for 130, it will first access the middle item. Middle item is this one. So 130 should be greater than this middle item, no? It's greater than 65. So it will go to the right side of the list. Then what should happen? So this left side discarded. This side discarded. You just want to search the right side only. So half of the search is gone now. So that is the advantage of binary search. Then it will go and access the middle item, which is probably 120. And then, so 130 is still greater than 120 means half of this list can be discarded. Now you have only two. And you just search. So next will be like 140, but no, 130 is not found. So you return false. So it's like this. So always half of the list is discarded by searching the middle item. Let's say, let's search for a valid item, the 34. So can you tell the steps? Can you repeat the steps to search 34? Yes. From where we have to start? Siddhas?
From 2.
From, no. From the middle.
Hello?
Yeah, from where you have to start? From the middle actually. So you have to start from 65. Is 34 greater than 65 or less than 65? 34, is it less than 65 or greater than 65? If I search 34, then how it search? So you have to search from the middle. First you have to go and access the middle item. Middle item
Yes,
is
sir.
6.
I couldn't hear you explaining the process. Could you explain it again?
Right, sure. Okay. So what I was telling is basically about the binary
Sorry.
search, right? The topic is binary search, and in binary search, basically it is applied for a sorted list. How search is done? So if list is sorted, okay, if you're searching, if you're searching this list, if this is sorted list, so what will happen? Basically, you have to go and access the middle item. So what is the middle item in this list? What is the item in the middle? Yeah,
65.
65. Okay, whether 34, is it less than 65 or greater than 65?
Less than.
Less than. Then you can discard the entire list. After this part you can discard. So that's the idea of the list. This part is discarded. No need to search there because this is already sorted. So it should be less than 65. And you have to search this one. Then you go and access the middle item. What is the middle item of this list? 34.
34.
Yeah, it is matching with the particular search. So your search found. So actually this is how the binary search applies. So it will always go to the middle and start searching because it is search, it is already sorted. So if you have 1,000 items in the list, how many searches you need to find an item? If you have 1,000 items in the list, how many searches you need to find an item in binary search? Okay, first round 500 items will be discarded. Understood? Round one. So if you have 1,000, round one, 500 items will be discarded because one side you have to remove. Round two, how many items discarded? Yes, 250 items will be discarded. The worst case scenario, I'm telling, if item is not found, right? පළවෙනි 10 හොයනවා, first 1,000 you search, you have to forget 500 items. Why? You go to the middle and check whether is it greater than or less than. So it should be either less than or greater than. Then you have to discard 500 items. Understood the concept or not?
Mm-hmm. Yes. Yes, sir.
For an example, okay, assume that you are searching a large list and this here you have a lot of items. Okay, likewise you have a lot of items here in the middle, in the initial stage, like one, two, those items in order, right? So assume that you are searching for 34. You go and access the middle item. Assume that middle item is 9. Then this part you can ignore because all these items are less than 9. So no need to search there, no? Understood?
Yeah.
So in the first round, 1,000 items, 500 items will be discarded. The first round. Second round, another 250 items will be discarded. Next round, another 125 items will be discarded. Next time, another 60. So around 60, closer to 60. Uh, yes, 62 items will be discarded. Then 31 items will be discarded. Next, 16 or 15 items will be discarded. Next round, 7 items will be discarded. Next 3. Next round, 1. So how many rounds you need to search? If you have 1,000 items in the list, it is 1, 2, 3, 4, 5, 6, 7, 8, 9. You need to search 9 times. That's all. The maximum is 9. So
9.
this is taken by, so if you have like 1,024 items, so this is taken by 2 to the power, so this is log 2n.
Right.
Right. So log 2n. So the worst case, the n will be to the 1,024. 1,024 means 2 to the power 10. Then maximum searches that you need is 10. It is less than 10. Understood? Right? Within 10 searches, you can find if there's an item. But in normal search, so what is in normal search, what will happen? Normal search එකක් ගියොත්, in worst case, how many times you have to search?
Yes.
Right? Let's say you have a list like this. This is not sorted list. Let's say marks. It's not sorted. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 items. And okay, let's say you have 10 items. You are going to find a number, search item, and you are going to search 9 in this list. And you are going to search for M in marks. So this is the loop. If M equal the search item, if M equal the search item, you are going to print yes print You have to tell, okay, found the item and just mention the search item there. Found the item and break. Okay, found the item and break. Okay, let's say you are going to maintain a count C equals 0. So in each round, you are going to increase the count C equals C plus 1. Or in each end of each round, you are going to count that C equals C plus 1. Okay, what will be the count at the end? So that's what I want to ask. This is called sequential search. Sequential search.python. So let's run this. So what is the number of count? So up at the end, 9 was not found. 9 was not found. So can you tell the value of C? What is the value of C? One by one items, it is checking. After the completion, what is the value of C? What do you think?
About 10.
Yeah, if you print the value, you can say C is 10. Because it has searched the first item, second item, third item, fourth item, fifth item, sixth item, seventh item, eighth item, ninth item, and 10th item, not found. So unfortunately, value is 10 to find 10 items. So what if it is 1,000 items? What if it is 1,000 items? It is 1,000, no? So if not found, the worst case means if it is not found, no, then it is 1,000. Right? Then it is 1,000. Okay, can you write like a sequential search? So this is not there in the book, but write the heading sequential search and show this. Sequential search. That is not there. But better you know the traditional. This is called traditional sequential search. But let's learn binary search after learning this. Then only it will be clear. That's right. Please write this. Okay, you can see this is like, it has like sequential items 1 2 3 4 5 up to 20, but anyway it is sorted. What you have to understand is that. So let's search, right? So it's searching for 8, then the middle. Okay, it's found. So let me again go to the beginning and show you. Let's search for 8. You are searching for 8. 8 is here. First you will go to the middle of the list. First step, it's 10. 10 is the middle of the list, right? Then after that, you have to tell me after that where it goes. So 8 is less than 10. So where it should go? Again the middle.
Discard the ones on the right.
Yeah, you have to discard this right part and you have to go to the left part. Then in the left part, what are you going to select? Which is the
middle value.
Middle value. What is the middle value?
5.
5. Yes, correct. So it will go to the 5. That is the middle value. Then 8 is greater than 5. So what will happen? 8 is greater than 5 means the left side should be discarded.
Yeah.
Now you have to discard the left side and go back. Then it will take the middle value. Next middle value will be 7. And when you take the middle value 7, again 8 is greater than 7. So you have to discard the left side and you access the next middle value, which is 8, and it's found. Right? Understood? So it's very easy, but need to be sorted. That is the problem. So the list need to be sorted. If it is not sorted, you can't apply binary search. Right? If it is not sorted, you can't apply the binary search. Actually, the implementation is also given. So the found is false, search is failed, it is also false. The first item is first, max items, that is the list number of item. So while not found and not, the search failed. So not search failed means status. While not found, basically you have to continue. Then middle is taken by first and last divide by 2. That is the usual method, no? You have to take the first index, last index, divide by 2, and that is the middle. Then if middle equal search item, you just find whether middle is equal to search item. Yes, then found. Else the first item will be the last item. So sorry, else first item is greater than last item. You search whether first item is greater than last item. That means no search area left. And if first item is greater than or equal to last item, means first and last almost same, means nothing to search. Here, when it the first is 8 and last is also 8, then nothing to search. Then search is end. If not, again you have to get the last item and you have to check with the last item in the list. Middle item is greater than the search item. If yes, if it is greater than, the last item will be middle minus 1. Change in the upper boundary. And else, first item will be middle plus 1. Change in the lower boundary. So that is all. So can you implement this using Python? Oh, can you understand it? At least you should be able to understand. Right? Can you understand what's happening there in the code?
Yeah.
Right. So here let's map the code with the visual representation. Anyway, so if you know the pseudocode, that's all. But anyway, you have to implement this using Python. That's very easy because in Python you don't have this much of code. Right? Anyway, the found is false initially because nothing found. Search failed is also false. Search failed means if nothing to search, then you have to say search failed. And first is 1. Agree? First is this one. And last is, that's the last. First is and last is max items. Last is this one. First is this one. Last is this one. Mid is taken by 0 plus 19 divided by 2. 0 plus 19 is 19. 19 divided by 2 is, yes, 19 divided by 2 is what? 9.5 rounded to 10, right? It's 10. Then mid will be 10. So first it search if this 8 equal 10, no. If 8 is equal 10, no, it's not equal. So not found in. It will go to the else part. Then it will search first equal last. First means 1, last is 20. Those are not equal. So you can still search. Therefore, it will go to the else part. The list middle item. Middle item will be the 10th here. This one. So you can say 9th or 10th. You can it depends on the algorithm, right? So let's set 9th one, 9th index. 9th index again බිඳුවයි 19යි එකතු කරලා 0 plus 1 19 divide by 2. Integer value is 9. 9th index is 10. Okay, then take the middle. Search item, middle greater than search item. 8 greater than 10, no. Middle greater than 10, no. It's no. 8 greater than 10, no. Then go to the else part. In the else part, what it does? First equal, in the else part, what you do? First equal middle plus 1. If middle is, if middle is greater than, middle means 10. Sorry, my mistake. Here middle means 10. Middle means 10. Is it greater than search item 8? Yes. If it is 10 greater than 8, if it is yes, middle equal middle minus 1. Sorry, last equal middle minus, then last will be middle minus 1. Then last is, earlier it was 20. Now new last is, middle is 9. 9 minus 1 means 8 is the new last. Understood? Hello?
Yeah.
Right. I think it's easy. So that's how you
Hello?
implement the binary search. Right? So binary search can be applied for a sorted list only. Okay, let's move. Then the remaining part is this one, queue. Actually, queue we discussed last day, how the queue is implemented, and linked list. We should know what is linked list. So unlike the list or tuple or array, linked list is a basically kind of list pointing to each other. So it has just, So here in the linked list, you can see the starting pointer. This is nothing actually when it is empty. But if you have a node, node has two things. Node has data and link to the next node. This node has data and link to the next node. This node has data and no link to the next node means this is the last node. Right? Try to identify, try to understand this by visuals. That will be easier for the exam. Okay. Start in, you have link only, you don't have data. Then data and link. This link is pointed to the next node. Then data and link. This link is pointed to the next node. Then data and link is not pointing to anything means this is the end of linked list. Right? Here node is an element of the list. Pointer, a variable that stores the address of the node it points to. Pointer. Null pointer, a pointer that does not point in anything. This is null pointer. This null pointer does not point anything means end of the list. Start pointer, a variable that stores the address of the first element of the linked list. So these are the key elements that you need. Okay. How to insert a new node? New node A is inserted at the beginning of the list. Right? How this is done is basically the content of the start pointer is copied into the new node. The content of the starting point is this one, will be copied, is copied into the new node's pointer field, right? And starting pointer is set to, starter pointer is set to point to the new node A. So did you understand that, or is it complex? When you insert in a new node here, what you have to do? Starting pointer should be pointing to this node. And whatever they are in the starting pointer should be copied to this one. So that's how you insert to the front. And insert into the rear. Or insert into the end of list. That is easy. So null pointer. So basically null pointer you have to remove. The new pointer will be pointed to this one here. Insert to the end of list. The pointer field node L points to the new node. L point new node point point a field of the P node contain null point because it is the last one. And so how to add to the new node to the end of linked list? Right now you know. So this is how to insert to the end, how to insert to the beginning. Actually, the implementation part, is it there? No, it's not there. Basically, it's not there. But these nodes and data pointers are there. Right here it says, so let's assume the start pointer is a null pointer, and you can see data, and so 1 is pointing to 2, 2 is pointing to 3, 3 is pointing to likewise, the 7 is pointing to the null node. That's how this is created using a list. Maybe you can use existing here, creating a new list. You can use existing data structures like a list. List you can use existing data structures to create this linked list. So advantage of linked list, why this linked list is there? So what is the advantage of having linked list? Yes, anything special? Any advantage of having linked list? Yes, other than the list and tuple, other data structures, anything special? Right? What has happened last day when we created the stack using list? So we had limited size, no? So I think you can remember the previous day video, previous day thing. When we create stack, stack size was 5. And so yes, we have created a method to extend the stack. But if that method was not there, so what will happen? Stack will get populated and filled. Stack will be full. But do we have such thing in linked list? Linked list, is it a fixed size or can we extend?
we can
We can add
extend
the
it?
elements and extend. We can add new elements and append, and extend this. There's no limitation, no prejudgment. So in the stack, we said stack was when stack was implemented using an array or list. We have to fix the size of stack and stuff. Or if queue is implemented using an array or list, we have to fix it. But if queue is implemented using linked list, then it will be more flexible because you can add new items. No fixed size. It is dynamic and it also knows about the neighbors. Here, if I say next, it's here. If I say next, it's this one. If I say next, it's this one. It knows about the neighbors. That is the second advantage. The disadvantage is it adds additional complexity to the code. That is the disadvantage.
Mm-hmm.
Right? Adds an additional complexity to the code. Okay, let's see the visual side of this. Let's visually see the representation or the. So I always advise you, please don't just read this because reading might be complex. But if you
Mm-hmm.
can, so nowadays you have enough facilities. You can visually see what's happening, and then it will be easy to understand. See this for an example.